Inverse trigonometry, written and presented by me, Jean Legui. This is illegal stuff. Right, quick reprise of what trigonometry did for you. Trigonometry, if you have a right angled triangle, one angle and the length of one of the sides, you can use trigonometry, which is the sine, cosine and tan functions, to give you the ratios of the other sides. That allows you to find the lengths of the other sides. So, trig functions are opposite over the hypotenuse equals sine theta, adjacent over the hypotenuse equals cosine theta, and opposite over the adjacent equals tangent of theta, where the angle is theta. Trig is just a sausage machine. You put angles in and you get ratios out. You just look these things up in tables on your calculator. Inverse trig, strange enough, does the opposite. You put ratios in and you get angles out. So if you have any ratios of the lengths of sides, you can find the angles. Summarizing, sine theta, where theta is the angle, equals opposite over the hypotenuse. Inverse sine of opposite over the hypotenuse gives you the angle theta. Cosine theta equals adjacent over hypotenuse. Inverse cos of adjacent over hypotenuse equals the angle theta. And tan theta equals opposite over the adjacent. Inverse tan of opposite over the adjacent equals the angle theta. So inverse trig takes the ratios and gives you the angles. Sometimes we write it arc. Inverse sine is sometimes written arc sine. Inverse cos is sometimes written arc cos. Inverse tan is sometimes written arc tan. We have the inverse trigonometry machine, which takes ratios and churns out angles. You have the inverse sine machine, which takes opposite over the hypotenuse and gives you the angle. You have the inverse cos machine, which takes adjacent over the hypotenuse and churns out angles. And you have the inverse tangent machine, which takes the opposite over the adjacent and churns out the angles. Inverse trigonometry. If you have a right angled triangle and two sides, you can use inverse trigonometry to find the angles. Either inverse sine of opposite over the hypotenuse equals the angle, or inverse cos of the adjacent over the hypotenuse equals the angle, or inverse tan of opposite over the adjacent equals the angle, depending on which sides you have. Practical use for this. I have a ladder and I want to find the safe angle to lean this ladder at. Now, that's what I want to find, the safe angle. I know that I should, for every 4 I go up, I should have 1 coming out. That's a right angled triangle with the opposite is 4 and the adjacent is 1. So I'll use the tan function. Inverse tan of opposite over the adjacent equals the angle theta. And the opposite is 4, the adjacent is 1. So inverse tan of 4 over 1 equals theta. I just look up 4 over 1, which is 4. I just look that up in the inverse tan tables, and that tells me that inverse tan of 4 is 75.96. So the angle is 75.96 degrees. Another example. I need to shoot down a missile, and I need to shoot it down using my high-powered laser. I need to shoot it down, let's make that a bit smaller, I need to shoot it down when it's 9.5 kilometers up in the air. And I need to shoot it down when it's 18 kilometers away from me. So I need to know what angle to fire at in order to shoot it down at 9.5 kilometers altitude, 18 kilometers distance from myself. The angle there, that's what I want to find. So this time what I've got is I've got the opposite and I've got the hypotenuse. And the one that goes along with that is the inverse sine function, because that's got opposite and hypotenuse in it. Inverse sine of opposite over hypotenuse equals the angle. Opposite's 9.5, hypotenuse is 18. 9.5 divided by 18 is 0.5278. I'll just look up inverse sine of 0.5278 and it comes out as 31.8554 degrees. So that's the angle to set my laser at. In summary, if you have a right angle triangle and two of the sides, you can use inverse trigonometry to find the angles.